I'm still working in section 3.4. This is Susan Poss. This is the third video, so I've numbered this 3.4.3. We're looking now to solve inequalities that require me to use the multiplication property. So we're going to start out just by looking at a couple of statements and observe what happens as we multiply both sides of the inequality or divide both sides of the inequality by something. So we start out here with a true statement, 5 is less than 10, and we want to multiply both sides by positive 2. So you see that I've multiplied both sides by 2, and that is still a true statement. 10 is still less than 20. So let's come down and try another experiment. This time let's multiply both sides by something that is negative and see how that affects the true statement in the inequality. So this time I'm going to take the negative 3 as a multiplier on both sides. So I have negative 15 is less than negative 30, which is not true. How do I know that? Well, let me think for just a minute about a number line. Here's 0, here's negative 15, and here's negative 30. And of course, negative 15 is not smaller, it's actually larger than negative 30. So when we're working with multiplying by a negative value, what happens is the inequality has to then be reversed. So as soon as you start introducing that multiplication or division by a negative value, you want to take whatever direction the inequality had, and you're going to want to turn it in the other direction. All right, so that's something you're just going to have to memorize that and remember it. This is also true when you're dividing by negative, because actually dividing when you're dividing by a negative, you can think of that as multiplying by a negative fraction. So they're very interrelated, but you'll hear me say dividing by a negative. So here's our rule. When multiplying or dividing inequalities, by a negative number, you must reverse the inequality sign. Okay, that's something you're just going to have to memorize and keep straight in your mind, and do your best to try to keep that special little rule in place. So here's our first one that we're going to solve, graph, and write in interval notation. And you can see right off the bat here that I have a numerical coefficient in front of that variable x. So I'm going to need, that is negative, so I'm going to need to divide both the left and the right side by negative 3. All right, so when I do that, this now becomes x is greater than or equal to negative 4. So notice how I took an is less than or equal to and reversed it into an is greater than or equal to. So let me find, we'll say this is negative 4 down here, 3, 2, 1, this is 0. We want all the values that are greater than negative 4. So here's my graph. This takes me all the way out here to positive infinity. And then the question becomes, how do I want to treat this end point back here? Do I want a bracket around that, or do I want a parentheses? And because it says greater than or equal to, I'm going to put a bracket here. So that's my graph. So here's my inequality statement, here's my graph, and now let me put it in interval notation, just sort of following the way the number line graph looks. Okay, this next one, 2m less than or equal to 12. I think you can see I'm going to be dividing by 2 on both sides in order to get that to a positive 1m. And notice since I was dividing by a positive value, I don't reverse anything. I want to show you all the numbers less than or equal to 6. So the numbers that are less than 6 are down this way. We're going all the way down to negative infinity, and I definitely want to include the 6 because the less than or equal to. So there's my graph. And finally, putting it into interval notation looks like that. Okay, so one more of these. And this one you can see I'm going to need to be dividing by that negative 12 coefficient on both sides to maintain the balance. So this is where, and let me change the color here so we can see this. This turns to is greater than right there. And of course over here is positive 4. So let's say this is 4 right here. Oh, again, that is my inequality statement. Here comes the graph, greater than 4. And I'm not including the 4. It doesn't say greater than or equal to, it just says greater than. So this is my graph here. And finally, I'm going to put it into interval notation. And that's how it looks in interval notation.